Okay, we can start. So welcome back again after the last break. My name is Paul Stack. I'm Stack72 on Twitter. My email address is on the bottom left. If you need to email me about any of this content, please do. This is a talk called Securing Applications and Infrastructure with HashiCorp Vault. Anyone know Vault? Yeah. Anyone use Vault? Very good, very good. Okay, so this is an experience report. Okay, this is actually really how we used it at a previous company. And I mean like within the last 3 months, 4 months. And we actually used it to secure an entire cloud ecosystem within the company we were building. I work for a company called Pulumi. It's not important in this case. I'm an automation junkie, and I just absolutely love everything to do with the DevOps space. So these types of talks are very much what I'm very interested in. So the problem space is, it doesn't matter if we're in operations or development, at some point, we're going to have to manage the issue of creating more secure applications. Okay? It's something that, unfortunately, we have not been very good at throughout the ages, and it's led us to all sorts of problems. Now, when I say we're bad at it, we really suck at it. And it's not something we like doing, because when it comes to security, we tend to get it wrong and then we get ourselves in some trouble. So we sort of palm it off and hope that other people take care of it within our organization for us. Now, there's a couple of very good examples of when things have gone horribly wrong within the past few years. And these are actually both from this year, where like unsecured MongoDB databases exposed like Kremlin's backdoor into Russian businesses. Earlier, like in September, almost all of Ecuador's citizens had their public information stolen because of a wide open Elasticsearch server. So this is like taking some cloud infrastructure or running some things in the cloud and then just forgetting to secure it. Or usually what happens is we'll come back and say, we'll put it up there now, and we'll come back and do the security part later once we have the applications running. Anyone ever been to the website, Have I Been Pawned? Anyone know this website? Okay, so this website is a fascinating experience to go and have a look through. So for those who do not know it, it is a website that is owned and managed by Troy Hunt, who is a security expert from Australia. And he basically collects all of the exposed information on the internet, like from companies that have been attacked and had their information stolen. And he puts it into one large database so that you can actually search it. So we can go and have a look at one of my old email addresses. Don't worry, I am going to share. So one of my old email addresses, a Hotmail address, has been hit in an Adobe breach, in Discuss, in a Dropbox breach, in Last.fm. I even had a MySpace. That's how old I am. You know, there's a lot of different ones, and like we can even put in my own email address right now, and I'm pretty positive that's also going to have been hacked or stolen in a breach at some point. Yeah, Bitly, LinkedIn, MyFitnessPal, although I don't look it, but that's a different story. So you know, you can really go and see that security is something that we're just not very good at. You know, you expect a company like LinkedIn to have very good security controls, but we have to remember, no matter how good we are, or how good we believe we are, or the security controls we have in place, there are always smarter people. And there are always people trying to beat what we're doing in place. So, back to slides. Move for me, there we go. So you can go and you can have a look at the website. It's like free, and you can play around with it. We really, really, really need to get improving in this area. Like, it's something that we're desperate at, and in the world of distributed cloud systems and distributed systems and creating more microservices and every microservice having its own database or its own document store or things like that, we really need to concentrate a lot more in this area. It's an area of DevOps that is very much rising because we've dealt with the development and operations aspect. Now we have to deal with bringing in the security aspect of it as well. So hands up if you run TLS on your production systems but your development systems do not use the same setup. Okay, we'll rephrase the question. Hands up who use TLS on their local development systems. Okay, this is good. Hands up who do not use TLS. Okay, so a lot more. Okay, you can see exactly what the issue is. So there's a number of things here. Firstly, the people who use TLS in your local systems, like big thumbs up, that's very good, and we'll talk about that very shortly. The people who use TLS in production, but don't use it in their development systems, you're partially the way there. The people who don't use it at all, please take one thing from this talk, look into TLS, right? If you're still using SSL, maybe migrate, because it was in 1996, it was deprecated in favor of TLS. So the problem is that if we are using TLS in production and not in our local development setup, then the first time we usually get access to how services interact with each other in a TLS manner is in production. And I can promise you from my own experience, all hell breaks loose. Really. And this is like, you hear so many excuses, well, it worked on my machine. Or I use Docker locally and I don't use Docker in production, and all these different things. Okay? You need to have an environment locally that sort of mimics what happens in production, because if you do not, then life will be more difficult for you when you push your applications to production. Let's consider the following infrastructure map. This is actually a set of microservices, okay, that are interconnected and they're talking with each other. Okay. Now this is a small segment of microservices. In the first talk this morning on game theory, there was a slide shown where there's like thousands and thousands of microservices. Monzo in the UK released like a map 3 days ago or 4 days ago that showed that they had 1,500 microservices. So this is a very small segment. Okay, but can you imagine having to debug this if the first time that you push these applications and in a TLS environment was the production? It would be an absolute and utter disaster, because application A could talk to application B and it could talk to application C, but 5 chains down the line, when you're talking to application G, H, and I, it could be a case of there's a TLS failure, and trying to walk the tree to do that is almost impossible. This is where HashiCorp Vault comes in. Okay. Now, I am a big fan of Vault. I have been using Vault at scale for a while. I don't use it now because I'm like out of the ops space. I'm back building tooling. But at a previous company, which I'm not allowed to say who the name is, but I'm sure if you're sensible and you can go to my LinkedIn, you can see who it was, then we actually used it in a large way. I'm not going to talk anything about getting up and running with Vault, okay, because that's a whole talk in itself, and there's a lot of learning material out there that you can go and have a look at. One thing that it's very, very important to say is how we actually did all of the work to get Vault running. Okay, so we had a 3-node Vault cluster, okay, which ensured high availability. You always run Vault with 1 active node and 2 standby nodes. Okay, that's just the configuration. We had a 3-node console cluster, which is another HashiCorp product, for service discovery, and also for the storage of Vault data. Again, you have to run it in odd numbers so that you can ensure quorum, because it's a quorum-based application. And the last thing is that each Vault node had a console client running on it so that they could understand and actually sync data between it all. And then we went one small step further, as we had a small TLS proxy called GoTon, which is like a tiny Go application that was sitting across the front of our Vault cluster, so that every time we made a request to the DNS, which was vault.myservice.com, it was always forwarding to the active node. Otherwise, you would have to query. Vault would tell you it's not the active node, and it would give you the URL to hit the active node, so you could have to make more than one request. Okay, so we cheated. We literally cheated. Now, I'm going to show you some Terraform code, how we actually structured this. But effectively, we are using the PKI backend. Okay, so it's a private key backend for Vault so that you can issue root certificates, intermediate certificates, and just normal service-based certificates based on everything we do. Now, there's 2 PKI backends that we enabled by default. Okay, so we had a root CA PKI because we wanted to keep it very, very. By the way, I'm not saying this is how you need to structure yours. Okay, please don't take this that this is the gospel truth of how you actually set this out. It's not. This is what worked for us. Okay, and it worked effectively for us. So we had the root CA PKI, which was a PKI that was actually created and a root certificate generated for 10 years and stored in a completely separate part of the file system from all of the rest of the requests because we wanted to have much more stringent backup strategy and also policies around regenerating it. Okay? The last thing we wanted to do was for someone to issue a generation request for a root CA, which would then invalidate the entire chain. So it had to be kept very specific, and it was locked down to system like administrators only. Okay? Then we had an intermediate CA that was mounted, and that was the one that could be recreated and destroyed at any time because an intermediate is the next level in the chain from a root. Okay, so you can regenerate the intermediate as many times as you want on the services below, but if you blow away the root CA, everything is blown away. Okay, so it's really important. Then we generated our root certificate. And even in my development environment, so this VN01, this was my data center. Okay, so Vilnius, it's the airport code for Vilnius in Lithuania where I live. And that was the root CA that was generated for my specific data center. When I say my data center, I had 15 VMs running on my local machine, and they were all talking to each other because they had a Vault cluster. We set everything up in exactly the same way locally as we did in production so that way we could understand what was going on. Okay, and you could see that it was $87,600, which is a 10-year certificate. Then after we have the root certificate, which, as you see, is pointed at the back end in the root CA path. Then we generated our CSR, which is our certificate sign-in request, and our intermediate certificate. So you must generate a CSR, otherwise services will not be able to generate a certificate against your intermediate. Okay? Any questions so far? Everybody just want coffee after the break? Yeah. So, because of this, we were able to, we knew our CA was created for 10 years. We could take down the level of our intermediates, okay? It didn't need to be 10 years because intermediates are effectively, ephemeral certificates that can be removed and replaced at any time because they're the next level down the line. So this one was actually only generated for a much shorter period of time. And then we had service-specific roles. Now, each service within our entire infrastructure had its own back-end role. So that meant that we could actually issue a specific request against a specific application or a piece of infrastructure. So in this case, this is actually the back-end role for CockroachDB. So Cockroach is like a Go-based database that's MySQL and sort of Postgres-esque, and it's a very scalable database, and this is actually why we used it. And this was a certificate that was generated for 1 week, and every time it expired, a new request would come in its way, and we could see that we could allow local host requests, we could allow IP sans requests, and we could generate leases based on the back of it. Now, this is extremely, extremely important. So you can see we've walked the tree. We've gone root, intermediate, and now we're creating the infrastructure that allows service-based requests on the intermediate. Okay? The reason that was because we used Nomad, another HashiCorp product. Anyone know Nomad? Anyone use Nomad? A couple. Anyone use Kubernetes? You should all look at Nomad. I'm joking. I'm kidding. So Nomad it's an orchestration-based tool, okay? It allows you to orchestrate your infrastructure, but it doesn't have lots of the complex overheads that Kubernetes has, which means it's a little easier to scale in and out and is useful in certain scenarios. Okay, of course, if you're using Kubernetes, you may have the reason for using Kubernetes, but if you're just doing it because of hype, then maybe something a little simpler can sometimes work. I'm a huge fan of it, and I will tell you everything about Nomad and why you should use it over all of the other orchestrators, but that's over a beer. So effectively, we had a few things going on here. We had a Nomad job. I need to somehow zoom in a little. Because this is a complex piece of kit. Okay, so firstly, we have a type, which is a service, so you don't need to worry about that. But effectively, we could say count equals 3. Okay, and it was 3 versions of a task. Okay, so like let's say we had 3 running instances of our database, so that we could actually have a much more highly available database across our entire cluster. Then we had vault policies. We'll come back to the vault policies in a second because it's interesting. But each Nomad job had a template that allowed it to contact Vault. Okay, this is why Nomad is extremely useful if you're using Vault, because its direct integration with Vault is fantastic because they're both owned by the same company. And we could say, issue a CRDB certificate based on the intermediate using that path. Okay, you can see that path right in the middle. And the TTL for that would be 72 hours. Okay, so 3 days. The common name will be a node, and then we passed in IP sans and an alternative name. Okay, so that would actually generate us a specific certificate for each of those CockroachDB clusters. Okay, and then we would save that output as bundle.json, and then every time that bundle changed, so for example, when the certificate expired, Nomad is clever enough to understand that the certificate has expired because of the TTL, and we generate least on the certificate, and it would actually regenerate the certificate, and it would send a sig hop. Okay, so it would basically restart the database cluster. Okay, but we used splay equals 10 minutes to say that we don't want all the database nodes to restart at the same time, because that would be a very bad idea. So they restarted within a period of each other of 10 minutes. Okay, so that means that we could take one node out of the cluster, the database cluster, and everything else continued to work, and we could like roll and swap them in. But then we also had this idea of an update. So when anything happened in the cluster, we were only able to update one node at a time using max parallel. So very quickly, we were able to isolate that when a certificate changed, only one node of the database cluster changed at any one time. In certain scenarios with types of infrastructure we were using, this count wasn't always equal to 3. Okay, so it wasn't always important that we had like a fully highly available system on our local machine. If we had one version of a database node working, as long as it worked in the same manner with the certificates and the alt name so that the certificate could be generated correctly and the restarting policy, it would be worth it and it would work very well. And the bottom of the certificate basically said, or the bottom of the job basically said, so the binary is called cockroach, and the arguments that we start in will be start, and the certificates directory would be the Nomad task directory. So where it downloaded those certificates from Vault and kept them, we would pass that in, and Cockroach was clever enough to understand that that's how it was actually going to start the infrastructure. Okay, so this is like, we were in a situation now that we could spin up multiple versions of database clusters, very, very, very simply, and they were all carbon copy of each other, like absolutely carbon copy of each other. It downloaded the correct binary, the correct version because everything was parameterized. It understood the correct hosts of within the cluster, and it could keep everything going when actually something changed, especially when it came to something with a certificate. And lastly, everything was registered as a service back in console, so we could see the health at any one time. Okay, so we could go to the console dashboard and say, oh, database is red, and then we could go and investigate very quickly why one of the nodes in the database or whatever happened to the database didn't work. We had many, many operations working in this manner. In fact, we had 18 different pieces of infrastructure working in the same way. We had NATs. If anyone knows NATs, it's a messaging technology. We had Nomad was actually backed by this. Okay, we had downstream console servers, so that we were using for service discovery. We're backed in this manner. We had written our own certificate managers for renewing and leasing of other pieces of infrastructure. So we had 18 pieces of production infrastructure, actual real infrastructure using this. That's excluding the applications. So we had a TLS-enabled database. How can the apps talk to it? Okay, now is where it gets much more interesting, because we have generated certificates based on the database, and now we need applications to generate user-specific instances of the certificate for the application based on that information in the database. And again, we had a console job for this. So again, we had our update, and again, we had the count. And the interesting thing about this was that the common name was actually the DB user. Okay? It wasn't like the DB alt name or anything like that. It understood that when I issue a request, because Cockroach, for example, is clever enough to realize that when I issue a certificate request using the name of a user, then it will give me access to that database from all sides within the cluster. Okay, as long as it's within the IP SANs of the cluster. Okay, that's why before we had a 127.0.0.1 address in there, so that we could make local host requests from the boxes themselves into the database to make queries. And again, we saved it as the user bundle.json. Okay, you can see it's exactly the same. Like really, there's very little difference in how we did this. The only mode here is that we didn't have a sig hop. We just restarted the raw application. Okay, because it wasn't necessary that we needed to send a sig hop in this case, because the applications were as stateless as they could possibly be and could go on and offline as many times as they needed to be because of how we designed them. But we still did have the update max one at a time, because we didn't want to destroy any end user availability based on any problems that we had with our jobs. And off the back of that, and the last thing just to say on that is each of the application-specific certificates were only issued as a max of 24 hours. So we went from 3 days for the entire cluster to a max of 1 day for the application. The reason that is that we knew we were going to be deploying the applications more than once per day, or at least once per day, so therefore we could actually reduce the TTL as much as possible. The golden rule is to try and keep the TTL as low as possible. Okay, so you don't have stale certificates running around, and you can actually control much easier what certificates are in the wild. So you keep that TTL low, and all those old certificates that don't support the correct stuff or have been updated throughout the ages will actually disappear, and you'll only get the new ones. And again, the application was just passed in some environment variables, which says the database host was a known database host because we were using console internally. And we had a TLS server name, which is node. We had a CA cert path, a client key path, and a client cert path. And they were all just files that were downloaded as part of the certificate from Vault. Okay. So I told you earlier about this Nomad policy, Nomad PKI. What this is effectively a policy that you can apply that basically says Nomad has access to do these things within Vault. Okay? So in this case, I can show you that Terraform, data center, modules, Vault data, policies. So we had an administrator policy that would actually allow us to create lists and issue new cert requests based on what we needed to do. So you can see secret paths, and you can see sysmounts, which is where the PKI backend is. So this was something that we could control, that we didn't have to give Nomad root access to our Vault server. We actually just told it it had a specific role that allowed it to actually have access to different things. So what do we actually have to change in the application? Okay. So the application was the most difficult part of this, because we had to structure our applications in a way that would allow it to read the correct things. So what I mean by that is, so we wrote in Go. We were Go developers. And we used Cobra and Viper, which is like a way of being able to create command line apps and read configuration that's passed into them in a very easy manner. Okay, so I think there's like Hugo, which is a blog engine in Go, is using Cobra and Viper. It's been a while since I've used it, like maybe 3 months. But at the top of when we had so we had an endpoint or a CLI command called serve, which would start a gRPC endpoint. And when it started the endpoint, it would basically say, go off and get the database configuration and get the gRPC configuration, and then it would create a new instance of a server and actually push that information out. Now, what that did internally is it went off and it just read strings. It read those environment variables, which was get the CA cert path, get the client path, get the bundle path, get the host, get the port, get the user, all of these different pieces of information, and it just created a DB configuration object and passed that DB configuration object into our code, and our code would then be able to say, oh yeah, I can connect to the database, or no, I can't connect to the database. It's very simple, very, very, very easy how we did this. And what we did is we actually made this cookie cutter. And I really mean we made this cookie cutter. Because if I show you the code, we have all of these folders. So that's actually, I can show you here, it's easier. If I tree depth 2, actually CMD, everything that's highlighted is a folder, and each of those was an application. Okay, like actually we had this many applications running in total. What? There we go. So we had an API gateway, we had serve, we had AZPM fulfillment, serve. Everything followed exactly the same pattern. Now, all of these services were built in a 6-month period. So we actually built a total of 130 services in a 6-month period. And it was a team of 5 people, 6 people that actually made these. So by leveraging these technologies and these different things, we were in a situation where we could roll these out very, very, very fast. And I can quickly show you some of the configuration code that allowed us to do this. Anybody have any questions? We have loads of time. Go for them, start now.
Okay, so you mentioned that Vault is in charge of like generating root CA and intermediate CA. So then which component is in charge of generating TLS for Vault itself?
Oh, very good question. So we had all of these systems that were, the question is, all of these things were talking to Vault to get their certificates, but what was doing the initial bootstrap of Vault? Is that correct?
Exactly.
Okay.
And not just initial bootstrap, but then rotation.
Okay, great question, great question, great question. So I'll start with the initial bootstrap. Okay, so the initial bootstrap was pretty simple. The reason being is that we had a script which took care of it. Okay, and we had a script which says configure Vault nodes, and it would actually just do the simple like bash install, because this was a one-step thing, right? Once we had Vault up and running, and once we had the initial connection of Vault to our backend console nodes, then that was it. And we were using Go template, or a Gomplate, excuse me, in order to actually pass in the correct configuration values that we needed per environment. So that part was pretty simple, because, as I said, it was once per environment, or per region, or per data center, and that was it. Now, when it comes to the renewal of Vault certificates itself, we had to write custom app. We actually had to write a custom app for this. And the custom app was called Cert Manager, because it managed certs, and we're bad at naming things because we're developers. And Cert Manager was a little more of an interesting thing. Okay, so we had an app called Renewal, and effectively Renewal would understand about the cert bundles and about our configuration, and it would just make HTTP requests to Vault to issue new certificates. It would then download those certificates, and because of the fact that we had Nomad, we were cheeky because we put a Nomad client on each of our Vault servers so that we could run specific jobs on those Vault servers. But those were tagged with like role equals secure, so normal jobs weren't able to run on those Vault servers. Does that make sense so far? And what we were able to do is we were able to download these certificates, and we were able to target specific jobs that took the outputs of the certificates onto the Vault servers and rotate them one at a time and push them out that way. So it was, once we had the initial bootstrap up, then at that point everything would actually work as expected. Now, I told you that each of the environments were built in exactly the same way. And I'm not kidding here, because if I go inside my Terraform configuration, we had a number of labs, okay? So lab ESP1 was the other guy on my team. That was his home environment, okay? Lab KR1 was actually a physical data center in Korea. Oh, I didn't say where that company is from. Lab LTO1 was where my environment was, and each of these had their own sort of setup inside them. So if I show you Lab LTO1, then we had configuration and we had VMs. So our VMs were using LVM in order to spin up machines, and we could understand and we could control exactly how much RAM and disk size was needed in each environment just by doing this. And everything had its own configuration and its own steps. And then in its configuration, we had a module that basically said, hey, look, here's the Vault module for Vault nodes, here's the Vault data module, here's the Vault Goton, which was the proxy across the front of Vault. So everything followed exactly the same structure. And because of that, the only thing that needed to differ was each environment just needed a list of IP address names, and more importantly, it needed a data center and a region name. Make sense? Keep going. Keep it coming.
Okay, so you just mentioned Monzo and 1.5K plus microservices they have, and they confirmed that they don't have mutual TLS. Do you think they are dumb, or maybe they have their own alternative vision on mutual TLS?
It's a great question. Do I think you need mutual TLS? Whatever way I say this is going to be wrong. That's a great question. No, I do not think they're dumb. I think they know exactly their ecosystem, and they know what they have to comply to, so they went with what worked for them. The reason we went with this specific setup is that this is what we were told by our parent company that we needed to have. Okay? Monzo are very specific right now because they're in a specific, like they're in the UK and they're moving to America next, and they understand the rollout of everything they have to do. So by no means are they stupid for not doing it. And I'm pretty positive that they're a little more secure than not mutual TLS. And like, you know, regardless if they have mutual TLS or not, they will know what they're doing, and they will know how to manage the security for their operation. Keep it coming.
Well, I have the last not really serious question, but why do you still own the code from your previous company?
Because this is, I still am allowed to talk about it. My previous company have been very, very nice actually and allowed me to talk about it because for them it's extremely good. The only thing I had to do was anonymize it because they didn't want the official company name in there and stuff like that, and they're pretty cool about it. So like my former CTO was very, very good, and he said, yes, you can like show some stuff on it. So. Any other questions? No? Anyone?
I can keep asking, by the way.
Keep coming.
So,
keep coming.
Like, okay, so I see this like a bare metal deployment, or did you use some kind of cloud with this setup?
So yes, great question. Was this bare metal only, or was it cloud-based setup? So for our local development environment, it was like bare metal. If you think of it as like bare metal, because we were creating VMs on our workstations. So it was like, you know, traditional style, here's like a vCenter style system, and you can go and spin VMs up against it. But all of the rest of the work while we were testing this was done on AWS and Packet.net. So it didn't matter because of how we actually provisioned hosts, those hosts would come up, they would have an IP address, and at that point we could configure them and we could understand what was going on.
Yeah, so the follow-up question here is that, because we are having kind of the same interesting issue, so we use ACM, and the problem that is like basically if you generate all the certificates on Vault, you need some kind of sync. So basically you need to like take the certificates from Vault and store it in ACM to then attach secret to the load balancer. And there is, I haven't found a tool or like a best practices approach how to do that actually.
So the question could be here, how do you, I think it would be a good way to synchronize data that comes from Vault into
because
ACM?
they have this private ACM thingy for $400, but then if you want to like do all the PKI related stuff on Vault, there is no like a proper way how to then take the certificate from Vault and store it on the ACM, so then it can be attached to the load balancer on AWS.
Got it. I could tell you the answer that I think, but it would probably be against the company that I work for right now. There's probably, to be honest with you, there'll be configuration management tools like Terraform or Pulumi. If you're interested, I'm joking. But yeah, like one of those tools will be able to like grab the information. So you'll maybe be able to make a request from one, and then you'll be able to use it as an input into another piece of information. I would suggest that that's probably the right way to do it. Otherwise, you would need to write something custom, and that doesn't really make any sense for the type of stuff you're doing, because it suggests to me as though it's an automated system anyway, and what you want to do is automate that last piece of storing it off. So I would definitely look at something like Terraform or Pulumi to do that. I really would. So. Okay, anybody else have any questions? Somebody almost went. No, okay. So for us, it became very interesting. Our key takeaways here, which is exactly what I think, even regardless of, like, it's a great question about Monzo, regardless of what we're doing, the fact that we're running mutual TLS, we're not running mutual TLS, the developers ran an exact infrastructure set up as production. Okay? And that was the key thing, because at no point were developers surprised by what was going on in production. They knew in advance that this was how System A talked to System B, to System C, and System D. And because of that, it made it very easy to crank out these applications. Now, we were going the traditional microservice style route of trying to keep our service in one bounded context, just to keep it doing one job so that we could control it very easy and we could understand what it was doing and not have too much custom different things happening within our microservice. So it was really very easy for us to be able to spin up 3 or 4 different pieces of what we call like a vertical or a platform. So like we were developing a cloud, okay, an internal cloud, and we had a platform, we had IAM, we had SSH keys, we had all this sort of stuff, and each piece of those had their own individual applications that were running. Okay, developers were able to run a full TLS setup on their local machines. Okay, so which was really good because it meant developers became much more confident with TLS. Okay, because it scares a lot of people. It even scares operations people, and they use it and understand it a lot more than developers supposedly use it a lot more and understand it than developers do. And what that actually meant was deploying to production environments was a complete non-event. What I mean by that is it just happened. Nobody had to think about it. There was no stress, no panic. And that's when we get into a full continuous deployment cycle of a single code change would get pushed into the repository, it would get built, it would run through our tests, and at that point it would be deployed and it would run out as expected. Okay. Because we did that, there was no such thing as what's happening in the industry at the minute of we must not deploy on a Friday, because that's crap. Okay, it's 2019. We should be in control of when we need to deploy for our customers. It doesn't matter when. But more importantly is that we were able to scale up and scale down and roll back and roll forward based on events that were happening within our system. Okay, I have only got a couple of minutes left. If anybody has any last questions. Keep them coming, man. I love it.
Okay, so can you please explain briefly how this GoTune thingy works? Because you mentioned that you placed it as a proxy, and then you always, so if I want to call Vault, it will always route to the active node. How does it work under the hood?
I'll show you GoTon after. It's probably
Okay,
easier, right? Just
yeah.
because it's a specific piece of Go application.
But I understood the purpose correctly.
Yeah. But if I actually show, I have like GoTon is an open source product.
Okay.
It's literally an open source project that we just thought we used to use HA proxy to do it, but like running HA proxy for this simple example was such a huge overhead. So GoTon was like a simple little like Go application that we just ran as a system CTL daemon. System D daemon, and it just started up and it just understood the three boxes talking to each other. I can show you the code for that. It's pretty easy. Okay. So if nobody else has any questions, I want to say thank you. It's been very, very, very nice being back in Kiev, and I'm hoping there'll be some people around later for a drink. I enjoy a beer. You can come and find me, so thank you.